We're now.
Yeah, good evening to all. This is Navneet Krishnan from iitiansgateclasses. In this section, we'll be dealing GATE 2018 flight stability problems. Flight stability problems. 2018 question number 12. The pitching moment of a positively cambered NACA aerofoil about its leading edge at zero lift angle is option A negative, option B positive, option C indeterminate, option D 0. If you see any aerofoil, the aerodynamic center of a subsonic aerofoil lies at the quarter chord point. For a supersonic aerofoil, same point lies at the off chord point. So, about aerodynamic center only your lift and drag acts. If you resolve this as a moment about leading edge, it will be always a nose down moment. According to sign convention, nose up pitching moment is positive, nose down pitching moment is negative. So it is a nose down pitching moment, so it's a negative. So it is option A, negative. Next. 2018, question number 41. A statically stable aircraft has a CL alpha, that is lift curve slope equal to 5, where angle of attack is measured in radians. The coefficient of moment of the aircraft about the CG is given as CMCG equal to 0.05 minus 4 alpha. The mean aerodynamic chord of the wing is 1 meter. The location positive towards the nose of the neutral point of the aircraft. From the center of gravity is dash in meter. They want location of neutral point from the center of gravity location is dash meter. We know that CMCG is given as 0.05 minus 4 alpha. When I differentiate this with respect to alpha, it is dou Cm by dou alpha equal to minus 4. Dou Cm by dou alpha equal to minus 4 per radian. Minus 4 per radian. CL alpha is given as, which is AW, nothing but 5 per radian. We know that dou Cm by dou alpha for an aircraft is given as minus AW into Hn minus H. Dou Cm by dou alpha, we already got it, minus 4. AW is 5, so it is minus 4 equal to minus of 5 into Hn minus H. So 4 divided by 5 is nothing but Hn minus H equal to 4 divided by 5 is nothing but it is 0.8. 4 divided by 5 is nothing but 0.8. Since they are telling that it is positive towards the nose, since Hn minus H is towards the trailing edge, Hn minus H value is towards the trailing edge, so it is negative value. Hn minus H equal to minus 0.8. Yes, they have mentioned that it is positive towards the nose. That means towards the tail, it is negative. So it is minus 0.8. So accurate answer is minus 0.8. In actual scenario, only In actual scenario, it is 0.8 only. Usually we measure from the leading edge to the trailing edge. But here, towards the nose, they have given it as positive already in the sign convention. That means it will become negative. Yes, Satish.
Sir, generally for finding the neutral point itself, we will make the dou Cm by dou alpha or dou Cm by dou Cl to 0, no? Here,
But,
no. My basic doubt is, for finding H1 itself, we are making dou Cm
by dou alpha equal to 0. Yes, correct.
But here, the dou Cm by dou alpha.
Your voice is breaking, Satish. There, while making neutral point, that is different scenario. Where we have ensured that neutral, by the definition of neutral point, we ensure that Hn is nothing but at the location where dou Cm by dou alpha is equal to 0, because pitching moment doesn't change with respect to angle of attack or Cl about neutral point. Okay. But there is a CG location also in this, right? There is not only neutral point location in this. There is a CG location also in this. Definition of neutral point only says that, but the definition of center of gravity doesn't say that. Is that clear? So in that case, we would have ensured that dou Cm by dou alpha for an aircraft is nothing but AW into H minus HAC minus eta T into AT by AW into VH into 1 minus dou epsilon by dou alpha. In this, we would have taken for shifting CG location to neutral point. If I shift this CG location to neutral point, then my dou Cm by dou alpha will become 0. So this becomes 0 means H would have become Hn. Okay. So if I take on the other side, my neutral point would have become aerodynamic center plus eta T into AT by AW into VH into 1 minus dou epsilon by dou alpha. This is how we would have solved for neutral point definition. But this is not about neutral point definition. This is how the stability of the aircraft, where Hn minus H is your static margin. Is that clear, Satish? Satish? Yeah.
No, I was not able to hear you actually. I just went out and then again I logged.
See, the definition of aerodynamic neutral point is something different. Where here it is not only neutral point location, it is also CG location is also present. Neutral point only says that dou Cm by dou alpha is equal to 0. But CG doesn't say that dou Cm by dou alpha is equal to 0. About CG, there is always a dou Cm by dou alpha value is present. Same way, if you take, this was your equation of dou Cm by dou alpha value. That dou Cm by dou alpha equal to AW into H minus HAC minus eta T into AT by AW into VH into 1 minus dou epsilon by dou alpha. In this, if I shift this to neutral point, then my dou Cm by dou alpha would have become 0. That's how we obtained Hn value. Hn value obtaining is different and the stability is different. Where Hn minus H is here static margin. Is that clear? Satish?
Sir. Yes, sir. I will ask you later, sir. No problem. You can proceed with the.
No, if you have some doubt, you can ask. There is only one more problem we have to solve. So you have enough time to ask. If you have some doubt, you can ask.
Rohit, no. In the next slide, 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 the next this dou Cm by dou alpha only you are making it to 0 to make that H as Hn, correct? No.
Yes, yes, yes.
So my doubt is exactly that, sir.
What?
Now this dou. Oh, you mean to say that equation itself is different, is it?
Yes, for the entire aircraft it is different, right? So this HAC,
No, this is for aircraft only, no?
This is for aircraft only. So okay, I'll rewrite this equation. This equation. Okay, I'll rewrite that equation. How it would have happened is dou Cm by dou alpha equal to AW into H. Okay, into H.
I think sir got disconnected. So let him come back.
Now you can hear me? Everybody can hear me?
Yes.
Yeah, I can.
Okay. See, from this what we have taken is Hn was equal to HAC plus neta T into AT by AW into VH into 1 minus dou epsilon by dou alpha. So H1 was HAC plus neta T into VH into AT by AW into VH into 1 minus dou epsilon by dou alpha. So this, in this equation, in the previous equation, instead of HAC plus neta T into AT by AW into VH into 1 minus dou epsilon by dou alpha, I substituted as Hn. I substituted it as Hn. Okay. That's how, if I take minus sign outside, it has become H, A minus AW into Hn minus H. So this is how we got how this the equation of dou Cm by dou alpha as minus AW into Hn minus H. Because
Yes,
this
yes, perfect, sir.
clear right now.
Yeah, got it.
Yes, Rohit. Your doubt, I'm okay. You also got it. Okay. Thank you. Next, question number 55. An aircraft wind tunnel model have a pitch axis moment of inertia IYY of 0.014 kilogram meter square. Is mounted in such a manner that it is pure pitching motion about its center of gravity, where it is supported through a frictionless hinge. If the pitching moment derivative with respect to angle of attack is denoted by m alpha is minus 0.504 Newton meter per radian, and the pitching moment derivative with respect to pitch rate q denoted by mq is minus 0.0336 Newton meter per radian per second. The damping ratio of the resultant motion due to inertial disturbance in pitch angle is approximately dash. See, since they are dealing with pitching motion, this is nothing but the short period oscillation aircraft motion. The short period oscillation of the aircraft motion can be denoted by this equation: del alpha double dot minus mq plus m alpha dot divided by Iyy into del alpha dot minus m alpha by Iyy into del alpha equal to 0. This is longitudinal dynamic equation of short period oscillation. In this, if we write it in the form of characteristic equation, if I write it in the form of characteristic equation, the equation becomes as lambda square minus mq by m alpha dot by I double y into lambda minus m alpha by Iyy equal to 0. So this is in the form of generally short period oscillation or underdamped oscillation. From underdamped oscillation solution, this can be in the form of lambda square plus 2 zeta omega n lambda plus omega n square equal to 0. This is the underdamped oscillations equation, characteristic equation. Equating these two equations, I get omega n square as minus m alpha by I double y minus m alpha divided by I double y, where m alpha is given as minus 0.504 Newton meter per radian. M alpha is given as minus 0.504 Newton meter per radian. So minus of minus 504. I double y is given as 0.014. I double y is given as 0.014. So omega n is minus into minus, it will become plus. Omega n will become root of this value. So omega n becomes as 6 radian per second. So next, the second term, if I equate 2 zeta omega n, that is equal to minus m minus of mq plus m alpha dot divided by Iyy. In this, m alpha dot is not given, so we can assume it to be equal to 0. So minus mq by I double y. Mq is given as minus 0.0336 Newton meter per radian per second. Minus into minus, it will become plus 0.0336. 0.0336 divided by 0.014. Omega n is known, it is 6 into 2. Zeta is the only unknown. So zeta equal to 0.0336 divided by 0.014 into 2 into 6. So we'll get this value as 0.2. So damping ratio is 0.2. So it is less than 1. That means it is an underdamped oscillation. Zeta is less than 1. So it is underdamped oscillation. Any doubt in this? Where in this my is given as Iyy into Q dot, pitch rate derivative. Any doubt? If you have any doubt, we'll clear. Otherwise, we'll wind up today's class. In this class, we have solved K2008 aircraft stability problems. Thank you. If you have any doubt, you can ask. Otherwise, we'll wind up today's session.
Related to that mock exam, one question is there. Shall I read out, sir?
You can ask. You can ask.
Yeah. The question I'll read out.
Okay.
Consider an airplane with rectangular straight wing at dihedral angle of gamma is equal to 12 degree.
Gamma equal to 12 degree.
Lift curve slope of wing aerofoil section bracket constant over the whole span of the wing is close bracket is CL alpha is equal to 6.8 per radian.
6.8 per radian.
The roll stability derivative CL beta.
Is dash.
Per radian is. That's the question.
Per radian is dash. Okay.
Roll stability derivative they are asking.
Okay. Yeah. Okay. Only one second. When we derived the relation for lateral stability, we have derived. This is regarding lateral only, right?
Yeah, sir.
Okay. Yeah. CL beta for lateral stability is given as minus 2 gamma. Since it is in degree, gamma is in degree, so it is divided by 57.3 to convert into radian into dou CL by dou alpha into y bar by b into S gamma by S, where S gamma is the off wing area. Okay, so since S gamma is the off wing area, we can take S gamma by S as 1 by 2. Y bar is the distance where the lift is acting. So the total span is V. Since it's a rectangular wing, semi span is V by 2. Then lift is acting at the centroidal location. So this location is V by 4. Okay, because half of V by 2 is V by 4. So it is minus 2 into 12 by 57.3. AW is nothing but 6.8 per radian into Y bar by B. Y bar is V by 4. V by 4 by B is 1 by 4 into 1 by 2. So substituting that, we get it as minus 0.356 per radian. Satish, is that clear?
Yes, sir. Clear, sir.
Anybody? Any doubt?
So these formulas we have to remember, is it, sir?
Yeah, we have to remember. If you are lucky enough, they might give you these formulas. but not for lateral and directional stability. They have given this formulas. Sometimes for gas dynamics equations alone, they used to give formulas. But that also, I prefer you to mark up. Okay.
Sir, one more doubt. In gliding, no. Generally, how to find the time, sir? Suppose if it is any glider, if it is lifted some altitude, what is the time it takes to reach?
It is
To
nothing
reach the
but
ground.
sinking speed is nothing but h by endurance. Endurance is nothing but your time. Sinking speed is nothing but rate of glide, which is v infinity sine gamma.
No, I am talking
So
about gliding, sir.
I am also talking about gliding only.
Okay, okay.
Sinking speed is nothing but v infinity sine gamma, which is nothing but h by endurance. From an altitude h, you started gliding. So what is that? From which altitude you started gliding? Let us assume this is 1000 meter. This is 100 meter per second. Sine is 10 degree. Let us assume. Then we will get our endurance as 575 seconds. Total time it has took is 575.877 seconds. That means approximately 576 seconds it took for it to glide from 1000 meter altitude to 0 altitude. That is
Yeah,
the
thank you, sir. Okay.
okay. Thank you. Yes, Ashish, you have got some doubts. Yeah, Ashish, you can send it via WhatsApp so that I will answer your question. Yeah, thank you. Good night.